So I think it's time we can get started. Any question related quiz tonight?
Are you gonna give us formulas?
Yes, it will be provided with a problem statement. You don't have to. I think majority students in my class in previous semester, they just like they have the problem statement on the computer and then just write down their solution on the paper. You don't have to print the exam or quiz. So you guys never done analog before? You will see. Will be download to print it. I think for the quiz problem, you don't really need to print anything. Do we have to scan in our work? You can take a picture. I think take a picture is much easier. Of course, if you have fancy machine at home, that's also fine. Practice assignment. Oh, okay. I will do it after class. I will do it after class. I thought you guys like practiced before, but if not, I will make a like autolog test, so you can try like log in, scan your ID or something. I don't know. Yeah, I can do it after class, and you can practice that before the quiz. Another question. I'm not sure if we can download the problem statement from autolog. I tried logging myself using my own ID that never allowed me to log in. So I don't really know if you can download from there. But if I like separately post it's one question. If I separately post a PDF file on Canvas, those it happened before that they would just skip using the unlock and they just somehow the work by themselves and upload the work on Canvas. So I do not prefer to post a separate PDF on Canvas about problem statement. We won't be penalized at the end for using no. You will get flagged, but it's fine. I will receive notification that you will get flagged because you're using the phone, but it's okay. It's not considered as cheating or anything. There's nothing you need to worry about. It's one question, yes. Probably with several parts. I'm not sure yet. Another question. Do we submit Y on log or do we do it after? I guess what I put in the announcement was you do everything on log and then you exit and then you use your phone to take a picture and then submit. And of course, before exit on log, you need to put your final number in the box below the problem statement. So we just want to make sure that you don't change anything after you exit unlock. So basically you are taking picture and then within 5 minutes you need to upload on Canvas. Am I allowed to do the quiz in master? Yes, of course. You can do it in any place, but don't do it with your friends. You can. I think the library you can reserve room. For like 1 hour, 2 hours, something. I think I did when I was student. Yeah, you can do it anywhere. It does not need to be in a private space. No. Oh, thank you for the suggestion. So it's 5th for Martin. Yeah. Any other question about the quiz tonight? I'm not sure the system right now, but when I was a student, I remember I need to reserve online. There's some booking system that you can check the spot and time, and then you need to do it online. I don't know. I don't know now, but yeah. So let's get started for the is the quiz going to be in quiz submission assignment or will it be a separate? Let's do it one by one. Quiz submission assignment I already made on Canvas, so that is just a place you submit your final work. So after you're done with the quiz, you have a you write down your solution step by step, like what I'm doing in the class for the academic problems, and you take a picture and submit there. But the actual quiz will be a separate assignment I will make this afternoon. So that one will be through on, yes. Will the quiz include what we learned today? No, but you still need to stay here to get the bonus part for the class. Do we have to solve the specific unit in specific units? Do we need to run to nearest? No. Basically, let's say if you have Newton, you have meter, you have Pascal, you can have a final solution in Pascal, you can have a final solution back Pascal, that's fine. But don't write anything like you have Newton, you have meter, then you have PSI. Then that's if you need to run, then it's wrong. But if it's like using different units, that's fine. Yes, you should use a calculator. I don't expect you to do like a really hand calculation. I mean, without calculator. Yes, include the material from last class, yes. Only today's content will not be included in the quiz. Yes, I will release solution very soon. Probably I can do it now. No. I will do it after class. With multiple quiz from previous lecture with just a singular solution. Let's not ask a repeated question. I already answered once, so it'll be just one question. Yeah. Yes, of course. Homework 5 will be covered on the next week. Yes. So today's content is chapter 2.2. It's a statically indeterminate system. Oh, by the way, because late submission is allowed with penalty, so I will set the unlock from 6:55 to 7:40. They may, I don't know, because they never allow me to log in. So they may have the countdown time based on 7:40. But you should know when you need to submit, so you have, because previously someone complained to me that they cannot check the time. So make sure that before the quiz tonight, you have something to check the time, like a watch, a clock, or anything. I don't want like student complaining to me that after quiz that you don't know the time, that's why you send me a late and ask me to remove late penalty. So everything we learned in previous section, let's say for calculating reaction force is really static determinant system, which means that let's say if we have 3 unknown reaction force for 2D problem, we have 3 equations. So force in X, force in Y, moment about a certain point. We have 3 equations, we have 3 unknowns. We can solve these 3 unknown reaction force for a system when it is a static determinant system. So basically, let's say for this example I'm showing here, if we don't have this one, B, we don't have this one, we only have this one and this one. This is a typical static problem you learned before. So basically, we can do for this one. Actually, we can have force in X and force in Y. We solve it. But if we have this redundant support, now you have unknown reaction force, unknown reaction force, unknown reaction force, unknown reaction force. You have 4 unknown reaction force, and there's no way you can solve this problem. So this is like very common real life situation, because a lot of times we do have redundant support to provide extra safety. If you remember, we do have the safety factor and safety margin kind of thing discussed. And also this is a common real life situation. As you can see that there are so many redundant support for this bridge. So in the situation that if we have more than, let's say for 2D problem, if you have more than 3 reaction force, unknown reaction force you need to solve, then we do need an extra equation. So the extra equation comes from the deformation. So I think a simple example, let's start from the simplest situation as example to explain to you here. So let's say if we have a 1D bar clamped to the wall on one end, and I have there's a 10 force applied on this 1D bar, right? Then based on this one, yes, I know the reaction force should be applied by the wall to the 1D bar should be the same as the force applied, and it should be in this direction, so it stays in equilibrium. We can solve this reaction force. But what if I have a redundant support at this end? Now let's say at A and B, I have RA, or let's say AX, BX. Reaction force at A in the X direction, reaction force at B in the X direction. Now we still only have one equation, that is AX plus BX equal to F. That's the only equation we can get from our previous class. There's no extra equation. Then there's no way we can solve this one, because now we have 2 unknowns. We have only one equation. Of course, force in the y direction equal to 0, moment about any point equal to 0. Those are in the 1D, we don't need to use those 2. So only one equation, we have 2 unknowns. So in this situation, what we need to do to solve this problem is that based on these 2 boundary conditions, we know the total elongation of this 1D bar should be 0. So that will provide an extra equation. The total elongation between A and B should be equal to 0, because it's fixed on this side, it's fixed on this side. Displacement at A, displacement at B, this should be 0, right? So now, if this is point where the force applied, let's say this is point C, is a force, concentrated force F applied, then what we can do is that for the AC section, we know that it is tension in the AC section, and it should be elongation in AC section. And in CB section, it should be contraction and compressive in the CB section. So now we can use the equation we learned in the previous class, how to write the elongation in the AC section, how to write contraction in the CB section, FLEA, then the total should be 0. So now we have two equations. One is from statics, one from deformation we learned in chapter 2.1. Now, if we combine these two, we can solve AX, AY, because internal force in AC section should be in the same magnitude. Well, since it's tension, right, should be the same as the reaction force here. The internal force in CB section is compressive, so it should be a negative value, and it should be same magnitude as BX. So this one equation, it includes AX, BX. This one equation includes AX, BX. So we have two equations to unknown. We can solve this problem. So this is the simplest situation I can think of solving the statically indeterminate system. I hope this is like an easier way to explain what does that mean and how can we use the deformation as an extra equation to solve the problem. So in terms of the new equation, new theory, I don't think there's any new theory in this section. It's really more like an application of our deformation equation we learned in the previous section. So let's start from the example problem directly. So we have a steel rod. Diameter is given. Young's modulus given. Find the reaction at this is the B prime. B is end of this steel rod. Find the reaction at A and B. How to calculate reaction at A and B. So originally there's a gap. This is 0.2 millimeter between the free end of the B to the wall B prime. There's a gap. And apply a force here, 20 kilonewton, and find the reaction at A and B prime. And just without calculation, when we look at this problem, there might be two possibilities, right? So we know that, okay, when we apply force in this direction, there should be tension in the AC section. There should be elongation in the AC section caused by the tensile force. So we know that C will move in the positive x direction to the right or to the right. B, same thing. There's no internal force. When we let's first ignore this one. We need to check if there's a contact of B and B prime first. So let's first assume that there's no wall here. We need to consider what is the elongation caused by P. And if this elongation is higher than 0.2, it means that in real situation, there will be contact between the B and B prime. And B prime will have a reaction force, right? Reaction force generated when there's contact between the free end and the wall. And the second possibility is that, okay, I apply this P, and there's elongation in the AC section, and the same thing, B will move to the right. And if the elongation is lower than 0.2 millimeter, it means that there's no contact between the B and B prime. So the reaction from the B prime should be 0, and reaction from the A should be simply 20 kilonewton. Does this make sense or not? Two possibilities, either contact or not contact for the B and B prime. So before calculation, of course, we don't know. So let's calculate first to see if there's contact between B and B prime. The first step is to check if B will contact B prime. Of the force applied. So the first step check, which basically means that let's assume there's no B prime here first. If it's free elongation, what is the elongation? So the AC section is equal to P AC L AC E Young's modulus cross section area. What the PAC should we use for calculation?
Just P.
Yes, thank you. So it's simply 20 kilonewton. L, I convert to meter. I convert everything to Newton and meter. And Young's modulus, of course, I need to put it as Pascal. Cross section area. Diameter is given. D squared. So now, if there's no B prime here, and if it's free elongation, the calculated result is 0.5 millimeter, and this is greater than the gap 0.2. So of course, there's a contact between B and B prime. So now, since we have a conclusion, there's definitely contact between B and B prime, we can do the calculation in a different way, because now the internal force distribution in the AC and BC section is different. The internal force in the AC is not 20 anymore, and it's not 0 in the CB anymore, because there's contact between B and B prime. So now let's do the free bar diagram of the entire bar first. Free bar diagram and equilibrium equation of AB. Left side is A. So, since force P is in the positive x direction, let's put the reaction force at B in the negative x direction, and reaction force at A also in this direction. So direction is given, so the RA, RB should have magnitude. So from statics, we have force in the x direction equal to 0. RA plus RB equal to P equal to 20 kilonewton. First equation. Second equation is from the geometry compatibility. So geometric compatibility. So specifically for this problem, it means that elongation in the AC section plus elongation in the CB section should be the length of the gap. Make sense or not? It's everyone clear about this geometric compatibility equation? Elongation of AC section, elongation of CD section should be this gap length dimension. 0.2. Now, of course, based on the equation, based on the equation we learned in 2.1, we can write deformation equation for both AC and CD. So AC equal to internal normal force in the AC section, L of AC section, Young's modulus of AC section, but since Young's modulus and cross-section area the same for both AC and BC, let's use E and A. We don't need to put a subscript there. And of course, AC is in tension. So the internal normal force in AC should be a positive value, and it should be the same magnitude as RA, reaction force at A. L, AC, E, A. Similarly, we can write this equation for CD. So based on definition, internal normal force in the CD section Young's modulus cross-section area. What's the relation between the internal normal force in the CD and the reaction force at B? RB. What's the relation between the internal normal force in the CD section and RB? Reaction force at B point. Anyone?
Would it be P minus RA?
P minus RA. P minus RA equal to RB, right? Do you mean RB?
Yes, sorry.
So RB L C B E A. Is this correct or not? Is this correct or not?
Shouldn't it be negative since it's in compression?
Thank you. That's the key information here. Otherwise, if you don't put negative sign, then it becomes elongation here and elongation in the CB section and equal to this gap dimension, and you will get a completely wrong answer. This is a very important point I want to emphasize here. So far, no matter it's internal force, elongation, stress, strain, for tension compression, we always need to put a sign. Whenever it's tension, always positive. Whenever it's compression, always be negative. So we need to know that here is elongation, here should be a negative value, which means the contraction, and the sum of these two should be equal to the gap dimension. So now we can put all the numbers. Since we have both sections have the same Young's modulus and the cross-section area, we can put it here as a common coefficient. Young's modulus 208 Pascal. Cross-section area pi d squared over 4. RA LAC 400 millimeter So it's 0.4 meter RA minus 0.8 RB equal to 0.2, the gap dimension. So now here is the extra equation we have. And we combine this one with the equation from statics. Two equation, two unknown. We can solve for the reaction force at A and B. RA 16 kilonewton, RB equal to 4 kilonewton. Direction is already given here, so we get two positive values, which means that assumption of the direction of reaction force here, they are correct. So reaction force at point A is in the negative x direction, magnitude 16. Reaction force at point B is in negative x direction, 4 kilonewton. Any question for this one? Any question for this example problem? What substitution to use? What do you mean by what substitution? RA and RB. What do you mean by what substitution for RA and RB? Oh, well, this is a pure calculation problem, right? You have RA plus RB equal to 20 kilonewton, and you have this equation. Two equation, two unknowns. This is not content from in non-mechanics materials, it's a pure calculation problem. If you really want to ask me like how you calculate this one by hand, well, you can write RA equal to 20 kilonewton minus RB, and you plug it into this equation, you can solve the RB, and back to this equation, you can solve for RA. It's a pure calculation. It's not the content of mechanics materials, but of course you need to know for your quiz and exam. Any other question? So the key information here, you need to be careful here is that when you have a compression, you always need to have a negative sign. If you're clear about this part, this example should be simple enough. Now let's move on to a more complicated example problem. Of course, this is again static indeterminate because we can see that we definitely have redundant support. Using statics, we can only solve this one with 2 bar, because basically you can write the equation in y direction, you can write the equation about a moment about a certain point. You can solve it for if we only have two links here as a support. But if you have a redundant, you have the extra support, then it becomes the static indeterminate system. And purely from statics, we cannot solve this problem. So we need to find the reaction force in each bar. And of course, let's write the equation we can get from the statics first, right? Let's do the free bar diagram and the equilibrium equation of this ACE. And of course, I want to emphasize here that the A, B, C, D, and E, F, they are deformable, which means that they will have elongation compression when there's a tension and compression. But ACE is a rigid body. It's rigid body, which means that before and after rotation, before and after deformation, it will maintain at a straight line. So now, first step, let's do the free body diagram and equilibrium equation of ACE first. And of course, on this one, we have the force applied at this point, 15 kilonewton. And we also have the force applied by the AB link, by CD link, and by EF link. Let's put it as FA, FC, and FE. For the equilibrium equation, of course, first one, we can write the force in the y equal to 0. So we have FA plus FC plus FE minus 15 kilonewton should be equal to 0. And we also can write a moment about a certain point. And of course, you can choose either point. You can choose A, C, E, or this point to calculate moment equilibrium. It should be the same. So let's do the moment about point C. So now we need the equation, we need to have the moment generated by the FA by this 15 kilonewton and by FE. So if it's moment about point C, then FA will generate a clockwise. So I put a negative sign. FA. And moment arm becomes, I should put dimension here. You can check the dimension here. The moment arm should be 0.4 meter if we are taking moment about C. And now we check this 15 kilonewton. 15 kilonewton will generate a counterclockwise. So it's positive moment, 15 kilonewton. And the moment arm, check the original picture. See, this is 0.2 meter time 0.2. And the last one is FE. This one will generate a counterclockwise. So positive moment about point C, moment arm, this dimension 0.4. It should be equal to 0. So this is all the equation we can get from statics. Of course, this
Your phone into and do like Apple Play.
Do you have a question?
I really hope that the implication. Me too. I forgot flip flops already. You can stop it. Let's go buy it. But I don't even care. I don't even care about flip flops.
Please only unmute when you have a question. Only unmute when you have a question. The second one is geometric compatibility. So how should we write the geometric compatibility equation for this example problem? So let's say originally this one ACE bar is on a horizontal bar. So this is a C, C is the middle point. And after deformation, because the force is applied between A and C, so you could expect that the elongation in the AB bar should be larger than EF bar, right? So this exaggerate deformation, let's say after deformation, it looks like something like this. And let's say we have A prime. A moved to A prime, C moved to C prime, E moved to E prime. So how to write this geometric compatibility equation? And of course, we know that the AA prime equal to the elongation in the AB. So this should be elongation in AB bar. And CC prime should be elongation in the CD bar. And EE prime should be elongation in the EF bar. So how should you write this geometric compatibility equation? Anyone?
Maybe use the ratio of them. So like elongation of AB over elongation of CD equal to elongation of CD over EF.
AB over CD equal to CD over EF. Is that what you said?
Yeah.
Why there's a ratio like this?
The bottom ones are all on a straight line. Or well, it's all straight. It's two straight lines. So
Yes, it's just like
you can make you could like make a triangle on the bottom if you drew a third straight line. Like if you start at E prime and go horizontal to the left, you can
Okay.
make a straight a triangle. Yeah.
Okay. So you're saying let's say this is A B C. Let's say this is F point. Sorry, cannot use F. F is a top point. Let's say this is a H. So why we have the relation delta AB over CD equal to delta CD over EF?
I think it's different actually. Would it be H over A prime and then H over C prime?
Sorry, could you say again?
I'm not sure.
Okay. So any other student has any other opinion about the relation of the elongation here? AC over AA prime, AC over AA prime, C over AA prime equal to CE over CC prime. AC over AA prime equal to CE over CC prime. Why is that? why there's a relation between. No, symmetric triangles, I understand when you say symmetric triangles, let's say symmetric triangle, you can, let's run it this way. Let's say if you have symmetric triangles, you need to make a triangle first. So basically what you need to do is that you have these are the triangles, right? So you have this one over this one equal to this one over this one. This is use the symmetric triangles, but this is not symmetric triangles. You understand what I mean? Is this clear? If you extend the line AE, let's say to point O, and then you extend the A prime E prime to point O, and now this becomes the bigger triangle, and this is the smaller triangle, and then the correct equation should be AA prime over LA equal to CC prime over LC. This is the correct equation for symmetric triangle. This is not, because your equation here is not based on a triangle. Do you know what I mean? Is this clear? There's a very complicated equation in the chat. DAB minus DCD. DCD. This. By AC. So another solution is AB minus CD over A minus C. What is A minus C? C minus E. It's not this complicated. You guys just overcomplicate the thing. We want to find a relation between the elongation, which means we want to find a relation between the AA prime, CC prime, and DD prime. What is the relation between these three elongation? You need an endpoint. So basically the AC distance and delta CD minus delta EF over CE. Is it the same as what I said before? This is okay. Now you have the triangle. AB minus CD. This one. E over AC. CD over EF. This one. Yeah, I guess this one. Yes, this one is correct. Okay. Okay, but a simple way to understand this is that just imagine this is a trapezoid and this is a line, sorry, at the middle point. C is middle point of the ACE, right? So it's natural just to look at this trapezoid. You don't need to write all the lines and everything, this one minus that one. It's very natural to see that this one should be half of this one plus this one. Does this make sense or not? You don't make it so complicated. Of course, this equation is correct, but it doesn't need to be so complicated to understand. It's simply, this is the trapezoid, and C is the middle point of the ACE. So this one should be half of delta AB plus delta EF. Let me write down the equation. Equal to half of AB plus EF. Any question for this part? Any question for this one? The last chat message in the chat is correct. So basically you have the AC equal to CE. So basically you have the delta AB minus delta CD equal to delta CD minus delta EF. And in the end, you get the same thing. But what I mean that you don't need to make it so complicated to have this relation, because if you just think this is the top and the bottom of the trapezoid, and the C is really at the middle point. So it's naturally to get a conclusion that this CC prime, purely from geometry, CC prime equal to half of the AA prime plus EE prime. Any question for this equation? Okay, let's move on. For the deformation equation, we just use NL over EA for each bar. We can write the equation. Theta always equal to force in that bar. L, E, Young's modulus is the same for all three. Cross-section area of each section. L original length is also same, 0.5. Young's modulus doesn't matter because cancel out on both sides. Cross-section area AB, EF 50, CD 30. Can you do this using slope and using to solve y equal to what do you want to solve?
When you were using the ratios for the A, yeah, right there. I wanted to know if you could use y equals like mx plus b using the change in like the distance with the deformation instead of like.
Yes, but why make it so complicated? Do you want to write an equation of this line and then find a relation between this one, this one, this one? If let's say
Sometimes.
yes, but for let's say focus on this problem. If we already know that this is elongation in the AB bar, this is elongation in CD bar, this is elongation in the EF bar, and I want you to find a relation of these three dimensions. Is this the simplest way to consider this is the middle point of trapezoid, this is the bottom, and this is the top? Why do you want y equal to mx plus b? And you need to solve that. What is m, what is b? And then you figure out the relation here, here, and here. Don't make things overcomplicated. You really focus on what are the things you need to solve. You will not be able to solve the exam problem, quiz problem if you go too complicated of method, in terms of method.
Thank you.
Yeah, welcome. So now, as I said, Young's modulus, since the same material, it cancels out on both sides. We don't need the E. So for the L, it's also the same. Actually, we can ignore this term and this term. So we have for F C over cross-section area 30. it's millimeter, but we are writing everything in ratio, so we don't need to convert to meter square. That's fine. 1/2 of FA over 50 plus FE over 50. Now we have again three equations, 3 unknowns. This is the third equation, second equation, first equation. Combine these 3 equations, we can solve for FA, FB, and FC. And of course, how to solve these 3 equations is something you need to learn like before you take this mechanics materials class. So I give you the final answer directly. FA Newton, FC 3.49 kilonewton, FE equal to 2. I didn't see the message in the chat. Let's go back to the question. That'd be useful if it wasn't a midpoint. So what if C is not a midpoint? Let's say C just a random point between A and E, and C is not random. C is not a midpoint. Well, in that way, I think you can still, let's say, let's draw this line, and of course, the HE prime is parallel to the ACE. So AH, let's put a G, CG, EE prime, they're the same. And we can take care of the rest in the triangle. So now we have H A prime over E prime H A prime over E prime H equal to H A prime should be the bottom of the triangle. G C prime over E prime. Now it becomes this one over H A prime equal to HA prime over this one equal to CG prime over this one. And of course, using this one, you can solve the relation when C is not a midpoint, and basically the ratio between these two can be anything. It does not need to be midpoint. So this is help answer what if C is not a midpoint, how to find a relation between the 3. Would it be possible to reach a complicated problem like that, or usually more simple? This problem, it happened to be the middle point, so this is the easiest way to get a conclusion, the relation between the 3. If it's more complicated, we can use triangles. We just move this line parallel to here, and now we can find a relation between these 2. And of course, the relation of these 3, they are equal. So this is for you to solve what if C point is not a middle point, because now the ratio between this one and this one, or let's say ratio between this one and this one, can be anything. What did the instructions say about area? Area is cross-section area. Area is cross-section area. For the question in the chat, the cross-section area A, B, E, F, C, D is the cross-sectional here, here, and here. Is used for us to calculate the elongation in the A, B, C, D, and E, F. There's nothing related to, sorry, there's nothing related to this part. Could you just change the 1/2 in the trapezoid equation for an point between A and E? Yes, you can do that. Oh, you mean this one? No, I don't think you can do that. No. It's basically you find a relation between this one based on the whatever point C is in the AE bar, between the AE bar. And then you add the equivalent. Then it becomes a relation between these three. Any other question about this example? Yes, it's just coincidence. For something more complicated, I just explain using this one. This is suitable for C is any point between this A. Okay, let's move on to the third example because we only have about 10 minutes. So this is also a real life problem. The column is made from the concrete. You can see these are the concrete. Sorry, this is the steel rods, and the rest part they're concrete. And the actual force applied is 200 pips. And of course, this is compressive force for the structure. Determine the average normal stress in the concrete and each rod. Each rod had diameter 1 meter, and the entire structure had 4-inch diameter, but each rod is 1-inch diameter. How to find the normal stress in the concrete and each rod? The answer will just get given for each material. Any idea how to find the normal stress? Normal stress in the concrete and normal stress in the rod. Again, let's first do the free body diagram and equilibrium equation of the structure. Let's assume that the P SP as the internal force for each single steel rod. For one rod, we have 8 in total. And P subscript, I use the concrete. It's internal normal force for concrete. How to write this equilibrium equation? Anyone? If we set this one as the internal force of 1 rod, and we have 8 steel rods in total, and the rest part they are the concrete, and we use P concrete as the internal force for concrete. How to write the equilibrium equation? As I said, we have 8 rods in total, so in steel rod, internal force. E stand for equilibrium equation. The answer in the chat is very close, it's almost correct. Make sure that you put negative sign. Because it is compression, no matter for the rock or for the concrete. The internal normal force in both, they always should be compressive, negative.
Just a quick question about the Young's modulus, because I looked forward and I saw this in the homework too. So it has 29 times 10 to the third KSI. So is that just mega pounds per square inch?
Yes.
Okay, it's not 10 to the third PSI.
KSI equal to 10 to the third PSI, right?
Right, and then we're adding another times 10 to the third to it.
Yes.
Okay.
Yes. Here we intentionally wrote in this way because here we have the keeps. So why wouldn't you add it to the other side, making it positive? Adding to what side, make what positive? It's the same. Do you want to say that you make this equal to 0? It's the same. This is the same equation, right? This equation and equation I just wrote is the same one, right? No, it should be plus 200. Let's do a free bar diagram. Wait, let's say you have the rigid plate. You have rigid plate here. You imagine you have the 200 200 kips applied in this way, and you have the force applied by the rod and concrete to this rigid plate. Should be in the opposite direction or it should be in the same direction. I think it's easy to explain why it should be. Let's still write in the original form. How should I explain this one? Since we get used to everything in the positive and the negative x direction. Now, internal normal force. Let's say we have P steel and we have A steel. The rest part, they are concrete. We have the P concrete. And let's say this is a positive x direction. How do you write the force equilibrium equation in x direction equal to 0? We have 200 plus 8 steel rod plus the rest part are concrete equal to 0. Is this the same equation as this one? Is this clear? I guess you guys are confused, like now everything is in the vertical direction. It should be the same. It should be the same. So this one can be easily explained that the internal force is carried 200 kips is carried by both the steel rods and concrete. And since we know that when you apply a force in this way, the whole structure definitely should be in compression. There's no doubt. The whole structure should be in compression. So now, internal force for A steel rods plus concrete should be a negative 200. Or if you really want to like get used, go back to what we get used to, it should be, let's say, let's rotate in this way, and let's say this is the positive x direction. Then we have positive 200, and on the positive surface we have 8 steel rod, and the rest part that concrete equal to 0. This is the positive surface, this is the positive internal force based on sign convention. Now we have this equation, and these are two equations based on different understanding, but if you compare these two equations, it'll be the same. That's why, back to the information in the chat, why when you put a negative 200 is wrong. Geometric compatibility. How to write this one? Geometric compatibility. We know that since it's compression for steel rod, since it's compression for concrete, both of them will have the contraction. And since, well, you would not expect there's some separation between the steel rod and concrete, right? If the contraction should be in the same way. This is a rigid plate. So the geometric compatibility for this one is simply the contraction, the delta in the steel rod and the delta in the concrete should be the same. Otherwise, there will be separation between the steel rod and concrete. Make sense or not? And the third one is writing the geometric deformation equation. So for the steel rod, we have internal force in the steel rod, L, Young's modulus of steel rod, cross-section area of steel rod. And concrete, we have internal force in the concrete, L is the same. L for steel and for original for the steel rod and the concrete should be the same. Young's modulus are different, so and cross-section area of the concrete. So plug numbers, we can ignore the L to cancel out on both sides. PST, Young's modulus, 29, 23rd. Since we have keep and KSI, so it's okay to not, we do not need to change to PSI and pound. And we have diameter of one rod is 1 inch. And since we already said this is internal force for a single rod, so the cross-section area should be corresponding to 1 rod, not 8. And now let's check the delta for concrete. Internal force for concrete, Young's modulus 4.2. 10⁻³. The cross-section area should be the entire circle, which is pi. Well, okay. The radius is 4 inch. Check the original figure. The radius of the entire circle is 4 inch. So pi r squared. Minus the cross-section area of 8 rods. So 8 times diameter of each steel rod is 1. Now the rest part becomes the area of the concrete. So simplify this equation, we get 0.123 concrete. And we combine this equation with the equation from statics. We can solve the steel and the concrete internal normal force. Concrete equal to -7. Okay. And steel equal to negative. Which makes sense because both of them should be in compression. That's why we get negative value. The area of the concrete, the area of concrete is the area of the entire circle minus the 8 steel rod. Makes sense or not? The entire circle is, this is radius is 4. Okay. I need 1 more minute for solving the average normal stress. Thank you for your patience. So, and of course, for the concrete equal to the internal force, concrete over the cross-section area of the concrete, which is negative 100.7 over cross-section area, which is this part. So this is equal to negative 2.29 KSI. Normal stress in steel equal to internal force in a steel over the cross-section area of 1 steel, because the internal force we said has 1 rod. So we have 12.4 I for radius is 1, sorry. Equal to negative 3.8 KSI. Right now. Any question? So if no question, we're done for the class today. Sorry for running out of time. The EE again. This equation? Are you asking about this one? Okay. So originally I wrote this one is because we know that the steel rod is in compression, concrete in compression, and steel rod, if we set PST as 1 rod, we total have 8 in total. So 8 plus times 1 steel rod internal force plus the concrete should be negative 200 kips. This is what I already said, but some of you said, okay, how about we use like what we did before, write the free body diagram and equilibrium equation. Yes, you can do that. So since everything we did before is we rotate everything in the XY direction, in the positive X direction. So let's say I take this part and rotate it this way. Now this is the positive X direction. So this is the positive X surface since it's facing positive X direction. Now for the 8 steel rod, we have this one. For the rest part, they're concrete, we have this one. So the equilibrium equation becomes 200, which is in positive x direction, plus a steel rod plus concrete equal to 0. And if you compare these two equations, they're the same.
Okay, so in general, for our like free body diagrams for this class, should we always just guess that they're going to be in the positive direction and
Oh.
then write our answer negative at the end?
Let's combine it with the question in the chat. So y is negative 200. First, if you see something like this and it's distortion like this, you know that it's in compression. Make sense or not? If I apply a force like this, you know it's in tension. And your equation should be positive. Does make sense or not? Or let's say you don't know if it's really in tension compression, you can do it in this way. So now for this one, you write the equation everything in x equal to 0, and you solve these two equal to negative 200. You don't need to figure out if it's in tension compression.
For the second way you just said, where we draw the free body diagram,
Yes.
I'm just confused on in that method why you initially chose the internal normal forces to be to the right.
Do you remember the sign convention in the first class we talked about in statics? Static review.
Oh, okay. Oh, because you cut the structure in half for
How do you find the internal force? Let me ask you, how to find internal force? You cut running point through the structure, and then you get internal force. And if I rotate in this way, this is facing the positive x direction, this is a positive plane. What is the internal force sign based on sign convention? What is the direction of internal force?
to the right. I understand now. I was confused this whole time because I thought that was the whole structure, and I didn't realize that you cut it in half. So I understand it now. Thank you.
So sign convention say we draw it out of the cut. How should I comment on that one? Well, for internal force, yes, you can say that. Any other question? If it's in compression, why we are pulling the cut? This one, let me repeat again. This one means that we don't know if it's in compression or tension. We just simply do a free body diagram, and this is a positive plane because this cutting surface is facing the positive x direction. And based on the lecture content in our first class, review of statics, when there is a positive plane, how do you write the positive internal normal force on the positive plane? This is sign convention. It's not because of tension compression. And after you solve this one, and then you figure, okay, this one plus this one equal to negative 200. Then you figure, okay, well, it's in compression. Please review the statics part you will need for the quiz tonight. When we say deformation of the concrete equal to the steel rod, why we use one steel rod, not 8? Well, you can use 8, but our PST intention right here is only for one rod. You can use 8 rod and then use 8 force. It'll be the same. Make sense or not? You can use 8 rod, 8 cross-section area. But one PST means one rod. If I assume negative normal internal force for the EE would be this is a equilibrium equation based on a free body diagram. We can discuss in the group in the office hour Zoom link. So when we do the free body diagram equation like this, we are not assuming anything in compression or tension beforehand. It's purely based on you cut the random point of this structure. That is how you find the internal normal force. So since you guys get used to anything in the x direction, that's why I rotate in the x direction. Now this is facing the positive x direction. And based on sign convention check notes in the static review of the first class of this semester, when this is positive, plane, positive surface, the internal normal force, the sign convention for internal normal force, this is positive. We have to write in this way, no matter if we are not assuming tension compression. This one is based on assuming tension compression, but this one is purely free body diagram and equilibrium equation. And after you write this equation, you solve this one equal to -200, and then you figure out, okay, it's in compression. Does this make sense or not? We put this one in this direction simply because this is on the positive surface. This is sign convention of internal normal force. Did I answer your question or not? Did I answer your question or not? Yes, free body diagram always assume the sign convention. So you could say that if you're not familiar, like assuming is understanding this way, always this is standard procedure. This is always standard procedure. There's nothing wrong following this pathway. This is always correct. Then in this way, you don't need to assume, oh, its intention is compression. I don't really care. Any other question? Okay, if no question, we are done for the class today. And if you have any other question, you can come to my office. I changed to the office hour Zoom link. Thank you for coming and have a great day.